Determining whether different types of lighting can operate on a single dedicated circuit requires careful consideration of electrical codes, ampacity, and potential conflicts. The question involves a 20-amp circuit feeding a sign cabinet illuminated by a 6-foot by 15mm 6500 neon powered by a TEC22 electronic transformer, alongside 9 relevant 20-watt halogen light fixtures and 2 T12 high-output fluorescent tubes. The National Electrical Code, or NEC, Section 600.5 disallows any other draw or load attached to either the sign circuit or neutral. Based on the information provided, all the specified loads can operate on the same dedicated 20-amp circuit, assuming the circuit's ampacity is not exceeded. Ampacity calculations are crucial to ensure the circuit can handle the combined load of all the lighting components. Neon signs of 15mm typically draw 25 mA per foot. For a 6-foot neon, this equates to 25 mA per foot multiplied by 6 feet, resulting in 150 mA. The TEC22 transformer's current draw is unknown, but typically it draws less than 1 amp. 9 relevant halogen lights at 20 watts each consume a total of 9 multiplied by 20 watts, equaling 180 watts. When operating at 120 volts, this translates to 180 watts divided by 120 volts, or 1.5 amps. 2 T12 high-output fluorescent tubes, each rated at 40 watts, consume a total of 2 multiplied by 40 watts, equaling 80 watts. At 120 volts, this equates to 80 watts divided by 120 volts, approximately 0.67 amps. The total current draw is calculated by summing the individual currents for each component. The neon sign draws 150 mA, which is 0.15 amps. The transformer draws approximately 1 amp, the halogen lights draw 1.5 amps, and the fluorescent tubes draw 0.67 amps. Adding these values together, the total current is 0.15 amps plus 1 amp plus 1.5 amps plus 0.67 amps, which equals 3.32 amps. This total current of 3.32 amps is well within the 20 amp limit of the circuit, providing a significant margin of safety. Regarding potential conflicts between the different transformers and lighting types, there should be no issues if certain guidelines are followed. Firstly, the TEC22 transformer must be properly rated for the specific neon sign, ensuring it meets the voltage and current requirements of the neon. Secondly, the halogen and fluorescent lights must be compatible with the voltage and frequency of the circuit, typically 120 volts and 60 Hz in the United States. Thirdly, all connections must be made in accordance with the NEC and any local electrical codes to ensure safe and reliable operation. In terms of NEC compliance, the proposed configuration aligns with NEC Section 600.5. Firstly, the circuit is dedicated solely to the sign and its associated lighting, with no other loads connected to either the sign circuit or the neutral conductor. Secondly, the total current draw of all the loads is well within the 20 amp ampacity of the circuit. Thirdly, no conflicts exist between the different transformers and lighting components, provided they are correctly specified and installed. It is essential to verify that the TEC22 transformer is indeed rated for the specific neon sign being used. Transformers have specific voltage and current outputs that must match the requirements of the lighting it is powering. Using an incorrectly rated transformer can lead to inefficient operation, damage to the lighting, or even create a fire hazard. Halogen and fluorescent lights should be compatible with the supply voltage, typically 120 volts in residential and commercial settings. Ensure that the lights are rated for the voltage being supplied to prevent damage and ensure proper illumination. Electrical connections must adhere to the NEC and local codes. This includes using appropriately sized conductors, properly rated connectors, and ensuring all connections are secure and insulated. Improper connections can cause overheating, electrical shorts, and pose a significant safety risk. The NEC provides guidelines for conductor sizing based on the ampacity of the circuit and the type of insulation. Use the appropriate wire gauge for the 20 amp circuit, typically 12 American wire gauge or AUG copper wire, but consult the NEC for specific requirements based on installation conditions. Use connectors that are rated for the wire size and type being used. Ensure that all connections are tight and secure to prevent loose connections, which can cause arcing and overheating. Insulate all connections with electrical tape or other approved insulating materials to prevent accidental contact and electrical shorts. NEC Section 600 covers the installation of signs and outline lighting. This section provides specific requirements for wiring methods, overcurrent protection, and grounding. Ensure that the sign and lighting are installed in accordance with these requirements. Overcurrent protection, such as circuit breakers, is essential to protect the circuit from overloads and short circuits. The 20 amp circuit should be protected by a 20 amp circuit breaker. Grounding ensures that the electrical system is properly grounded to prevent electrical shock hazards. The sign and lighting should be grounded in accordance with NEC requirements. The total load on the circuit should not exceed 80% of the circuit's ampacity to prevent overheating and nuisance tripping of the circuit breaker. For a 20 amp circuit, the maximum continuous load should not exceed 16 amps. In this case, the calculated load of 3.32 amps is well below this limit. If additional loads are added to the circuit in the future, it is essential to recalculate the total load to ensure it remains within the circuit's ampacity and the 80% limit. It is recommended to use a clamp meter to measure the actual current draw of each component to verify the calculated values. This can help identify any discrepancies and ensure the circuit is operating safely. Regularly inspect the wiring, connections, and lighting components for any signs of damage or wear. Replace any damaged components promptly to prevent electrical hazards. If you are unsure about any aspect of the installation or have any concerns about electrical safety, consult with a qualified electrician. Working with electricity can be dangerous, and it is essential to take all necessary precautions to prevent accidents. Consider using energy-efficient lighting options, such as light-emitting diodes or LEDs, to reduce energy consumption and lower operating costs. LED consumes significantly less power than halogen and fluorescent lights, and they have a much longer lifespan. Additionally, LED do not contain mercury, which is a hazardous material found in fluorescent lamps. Light-emitting diode lighting provides comparable illumination while reducing the load in the electrical circuit. This can be beneficial when multiple lighting fixtures are required, and it can also reduce the overall energy consumption of the sign. Light-emitting diode fixtures are available in a variety of styles and configurations, including those that can directly replace halogen and fluorescent lamps. When selecting LED lighting, ensure that the fixtures are compatible with the existing wiring and voltage. Also, check the color, temperature, and light output to ensure they meet the desired lighting requirements. Using LED can significantly reduce the current draw, potentially allowing for additional lighting fixtures or other electrical devices to be connected to the same circuit within the limits of the circuit's ampacity. It is important to note that while the calculations show that the circuit can handle the load, practical considerations should also be taken into account. For example, the startup current of the fluorescent tubes in the transformer can be higher than the steady-state current. This inrush current can cause temporary voltage drops and may affect the performance of other devices on the same circuit. To mitigate this, consider using soft-start ballasts for the fluorescent tubes and transformers with low inrush current characteristics. Also, ensure that the circuit breaker is rated to handle the inrush current without tripping. If you experience frequent tripping of the circuit breaker, it may be necessary to install a larger circuit breaker or to separate the loads onto different circuits. However, increasing the size of the circuit breaker without upgrading the wiring can be dangerous and is not recommended. It is essential to consult with a qualified electrician before making any changes to the electrical system. Proper labeling of the circuit breaker is crucial for safety and maintenance. Clearly label the circuit breaker as sign circuit or sign lighting to prevent accidental overloading of the circuit. This will also help to identify the circuit quickly in case of a problem. Regularly check the circuit breaker for any signs of overheating or damage. If the circuit breaker feels hot to the touch or shows signs of discoloration, it should be replaced immediately. When performing any electrical work, always disconnect the power to the circuit at the circuit breaker. Use a voltage tester to verify that the power is off before touching any wires or connections. Follow all safety precautions and wear appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with the NEC and local codes. They can also help you to troubleshoot any electrical problems and ensure that your electrical system is operating safely and efficiently. Local codes may have additional requirements that must be met. It is essential to check with the local building department or electrical inspector to ensure that your installation complies with all applicable codes. Local codes may vary depending on the jurisdiction, and they may be more stringent than the NEC. Some jurisdictions may require a permit for electrical work, and they may require an inspection to ensure that the work is done properly. Ignoring local codes can result in fines, penalties, and even legal action. Staying informed about changes to the NEC and local codes is crucial for ensuring electrical safety and compliance. The NEC is updated every 3 years, and local codes may be updated more frequently. Subscribe to industry publications, attend training courses, and participate in professional organizations to stay up to date on the latest codes and standards. By following these guidelines and taking all necessary precautions, you can safely and effectively combine neon, halogen, and fluorescent lights on a single dedicated 20-amp circuit. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Always prioritize safety and ensure that your installation complies with all applicable codes and standards. Periodically examine the physical condition of the wiring, lighting fixtures, and transformers. Look for signs of damage such as cracked insulation, frayed wires, rust, or corrosion. Any damaged component should be replaced immediately to prevent electrical hazards. Also, ensure that the lighting fixtures are properly secured and that they are not exposed to excessive moisture or vibration. Moisture can cause corrosion and electrical shorts, while vibration can loosen connections and damage components. Protect the electrical components from environmental factors such as rain, snow, and direct sunlight. Use weatherproof enclosures and connectors to protect outdoor lighting fixtures and wiring. Direct sunlight can cause the insulation on wires to deteriorate over time, leading to electrical hazards. Also, ensure that the lighting fixtures are properly ventilated to prevent overheating. Overheating can shorten the lifespan of the components and can also create a fire hazard. Consider implementing a regular maintenance schedule to inspect and test the electrical system. This can help to identify potential problems before they become serious hazards. During the inspection, check the wiring, connections, lighting fixtures, transformers, and circuit breakers. Test the circuit breakers to ensure that they are functioning properly. Use a clamp meter to measure the current draw of each component to verify that it is within the rated limits. Keep a record of all inspections and maintenance activities. This can help you to track the performance of the electrical system and to identify any recurring problems. It is also helpful to have a record of all repairs and replacements. When performing maintenance, always disconnect the power to the circuit at the circuit breaker. Use a voltage tester to verify that the power is off before touching any wires or connections. Follow all safety precautions and wear appropriate personal protective equipment. If you are not comfortable performing maintenance yourself, hire a qualified electrician to do it for you. It is also important to consider the impact of the lighting on the surrounding environment. Avoid using excessively bright lighting that can cause glare and light pollution. Use shielded lighting fixtures to direct the light downwards and to prevent light from spilling into unintended areas. Consider using timers or motion sensors to control the lighting. This can help to reduce energy consumption and to minimize light pollution. Timers can be used to turn the lights on and off at specific times, while motion sensors can be used to turn the lights on only when someone is present. Choose lighting fixtures that are energy efficient and environmentally friendly. Look for fixtures that are labeled with the Energy Star rating. Energy Star fixtures use less energy and last longer than conventional fixtures. Also, consider using light-emitting diode lighting, which is one of the most energy-efficient and environmentally friendly lighting options available. Dispose of used lighting fixtures and lamps properly. Fluorescent lamps contain mercury, which is a hazardous material. Do not dispose of fluorescent lamps in the trash. Instead, take them to a recycling center or a hazardous waste disposal facility. In summary, combining neon, halogen, and fluorescent lights on a single dedicated 20-amp circuit is feasible if the total current draw does not exceed the circuit's ampacity and if all components are properly installed and maintained. The calculation shows that the total current draw is 3.32 amps, which is well within the 20-amp limit. However, it is essential to consider practical factors such as startup current, code compliance, and environmental impact. Always consult with a qualified electrician to ensure that your installation is safe and compliant with all applicable codes and standards. By following these guidelines, you can create a safe, efficient, and environmentally responsible lighting system.